Hello everyone. In this video session we are going to look at a question in a database which was asked in 2014 in set 2 for 2 marks. And the topic is SQL. The question goes like this: SQL allows duplicate tuples in relations and correspondingly defines the multiplicity of tuples in the result of joins. Which one of the following queries always gives the same answer as the nested query shown below? So here is a nested query that is given in the question, and then there are 4 queries. Those are given in the options, and we need to find out that query which has same result set as that of the query that is part of the question. Now it is said that SQL allows duplicate tuples in relations. Now theoretically a relation cannot contain duplicate tuples, because a relation in effect is a set, and set cannot contain duplicate elements, right? So relation is a set, so duplicate tuples theoretically are not possible. But when it is implemented by companies like Microsoft, Oracle or IBM, they decided to allow duplicate tuples or insert duplicate rows in table, and it is possible only when if there is no primary key of the table. So we can insert, if there is no primary key, we can insert duplicate rows in a table. But while querying from the table, we can use distinct keyword to get distinct tuples or distinct rows from a table. So duplicate rows are possible in SQL. That is, in case of practically or the implementation of relational algebra, it is possible that we can have duplicate tuples in result sets. So let us first attempt to find out the result set of the query that is given in the question. So it is a nested query in which the outer query is select asterisk from R, where AN, and the inner query or the subquery is select S dot A from S. So let us first find out what would be the result of the inner query. So the result of the inner query, as we have just a single column that is part of the select clause, that means we would have a single column in the result set of the subquery, and it would be column A of this relation S. So column A of relation S contains 1, 2 and 2. Now outer query is select asterisk from R, where AN. So all the rows of R would be selected where the value of A is matching with any of the values of this result set that we have got from the subquery. So if it is 1 or 2, then that particular row of R would be selected and would be added to the result set. So this row, the first row of relation R, has got value of A as 1, and which is one of these values that we have got from the subquery, so it would be part of the result set. So 1, 2. So if you see, we are selecting all the columns of relation R, right? So both of the columns A and B would be projected, and the first row has got 1, 2 here. Now again the second row would be selected because 1 is part of the result set of subquery, so this would also get selected. Now what about the third row? So third row would also get selected because 2 is part of the result set from the subquery, so this row would also get added to the result set. Now 3, 5, the fourth row would not get selected because 3 is not there in the result set of subquery. So this would be the result set of the query that is part of the question, right? Now we need to find out which one of these queries have same result set as that of this result set. So let us now first try the first option. Select R dot asterisk. R dot asterisk means project all the columns of relation R, right? So from R comma S, where R dot A equals to S dot A. That means we are basically joining these two tables on the basis of values of A of the rows. Wherever a row of relation R matches with a row of relation S with respect to the value of A, that means value of A's are equal, they would become, that particular row of R would get joined with the particular row of S with which it has matched, and it would become the part of the result set. And from there we would just project the columns of relation R. That means the final output would contain only the columns A and B. So now let us execute this this first query of option A manually. So how would this get executed is, each row of relation R would be compared with each row of relation S, and wherever there is a match with respect to value of column A, that particular row of R would get joined with that particular row of S, and that would become part of the result set, right? So let us first perform the check the matches of relation R's first row. So relation R's first row is 1 2, right? And now let us try to match it with first row of relation S. So it is 1 7, and the values of A of B of both of these rows match, right? So they would get joined and they would become part of the result set. So option A's result set would contain only two columns, because we are projecting only the columns of relation R, right? Had we projected all the columns of relation of this relations, then the result set would have contained A, B, A, C, means all the columns of both of the relations. But because we are projecting only the columns of relation R, so it would contain only A and B. So the first row of relation R has got matched with first row of relation S. So 1 2 would become part of the result set. Now let us match the first row of relation R with second row of relation S. So they are not matching because the values of A's of these two rows are not equal. They are not equal, so they would not get matched. Similarly with third row, it is not getting matched, right? And now let us compare or try to match second row of relation R with each rows of relation S. So 1 2 are the values of column A and B of second row of relation R. Let us match with first row of relation S, 1 7. So definitely the values of column A of both of these rows are same, so they would also become they would get joined and they would become part of the result set. And from 1 2 1 7, we are just projecting the values of columns of relation R. So 1 2 would again become part of the relation set. So let me, for the sake of completion, let me write other columns that we are getting as part of after joining these two relations, and put the values of that too. So first row of relation R has got joined with first row of relation S, right? So A, C are coming from the relation S, and here also second row of relation R has got matched with first row of relation S. So this 1 7 are coming from relation set S. But as we are projecting the columns of relation R only, so this would actually not become part of the output. right? So this I am just writing out for reference. Now 2 4 would not get matched with 1 7 because values of A column are not matching. 2 4 would get matched with 2 8 and 2 4 would get matched with 2 9. So these would also become part of result set. 2 4 2 8 and 2 4 2 9. 3 5 would not get matched with any of the rows of result set S. So this basically would be, so these are the rows of option A's result set: 1 2 1 2 2 4 2 4. Now if we match it with the result set of the question, they are not matching because 2 4 has got duplicated in the result set of option A. In effect, if you see that in the question we are selecting the rows of only the rows of relation R. So there would never be a case where the result set would contain any extra row that is not there in relation R. So the result set of this query in the question would always be subset of relation R's tuples, right? Whereas if we are joining relation R and relation S, then the result set might contain more number of rows than the relation R itself, and that is the case here. If you see, the relation R has just got a single row of 2 4, but here in the result set we have got 2 rows of 2 4. So option A is incorrect. Now let us come to option B. Select distinct R dot asterisk from R comma S where R dot A is equals to S dot A. So again we have we are joining the two relations on the basis of equality of values in column A in both the relations. So we would definitely get this result set, and on top of that we are applying distinct. So the result set of B would be 1 2 2 4, that is distinct of this relation, right? And it is also not same as that of the result set of the query in question. So this would also not be correct answer. So all the cases in which we have duplicate rows in relation R, in those cases the result set of option B would not be equals to the result set of the query in the question, right? So let us come to option C. Select R dot asterisk from R. Now we have a derived table here. Select distinct A from S. So this query would be treated as a table, and it is the term for it is derived table. So in place of this query we can actually replace it by a table that would contain result set of this query, and we can term it as the result set of this query as table S1. We can treat it as a table, and the name of the table might be S1, right? So first of all, find the result set. Let us find the result set of this derived tables. Select distinct A from S. So select distinct A from S would get us all the distinct values of column A of relation S, and those are 1 and 2. Those are 1 and 2. Now this table we are terming it as S1. This is alias and we are terming it as S1. So thinking S1 is a table, now we are joining R and S1 on the basis of values of column A. Wherever there is a match, a row of relation R would get joined with a row of S1. So we have R over here and we have S1 over here. Now the first row of relation R would get joined with first row of relation S1 because the values of A's are matching. So we have A, B columns coming from relation R, and we are projecting only the columns of relation R, but I would also attach the column which is coming from the relation S1, but it would actually not be part of the result set. Only these two columns would be part of the result set, but I would put it here for reference. So 1, 2 of relation R, that is first row, would get matched with the first row of relation S1, that is 1. Now 1, 2 of the that is first row would not get matched with second row of S1 because the columns A's values are not matching. 1, 2, that is second row of relation R, would get matched with first row of relation S1. So 1, 2 would again get added to result set. 2, 4, so 1, 2 again would not get matched with second row. 2, 4 would not get matched with first row. 2, 4 would get matched with second row. So 2, 4, 2 would become part of result set. 2, 4, 2, 9 would get matched. 2, 4, sorry about that. 2, 4 would get matched with so this is already done. Now 3, 5 would not get matched with any of the rows of S1. So this would be the result set of option C, and only this part, this A, B column, would be the actual result set, and this column would not become the part of the result set as we are projecting only columns of relation R. And as we can see that this result set is exactly the same as that of the result set of the query and the question. So this would be the correct answer. Now coming to option D, I have never seen a syntax like this, is unique R. I don't know why this was this became part of it seems to be invalid. So anyway, if we can assume that the professor who have asked this question wants us to join only those try to join only those rows of relation R which are unique in relation R. So with that assumption, let us attempt it. So the unique rows of relation R are 2, 4 and 3, 5, right? So 2, 4 and 3, 5 of relation R, and now if we try to match them with the rows of relation S, then what we are going to get is 2, 4, 2, 8 and 2, 4, 2, 9. And if we project only these columns, then we would get 2, 4, 2, 4, and which is not same as that of the result set of the query in question. So option D is incorrect. So with this we have eliminated 3 options, A, B and D. Only option C's result is same as that of the result set of the query in question. So option C is correct. So with that we have completed this video. Thanks for watching. Bye.